This is problem 6 from the H10-4 notes. It says find the sum of the following series. You may need to find the value of n first. Okay, so we're going to add a little something into this one here. This is supposed to be a kind of a practice from the previous problem that you did in the notes, but there's something we wanted to add in because I don't know if you've done this yet. You'll see our series. We have the sum of the first n number of terms is equal to 5 plus 10 plus 15 all the way up to 400. Okay, but we don't know how many terms there are, and we're going to need to know how many terms there are if we're going to find the sum of the series. It's not asking us to generalize like we were doing in the first few problems in the notes. This one we actually know how many terms or what the last term is, so we need to figure out what the term number is. And right, this is where you're going to use those equations that you came up with there in Algebra 1 and relearned here in 10-2 for the nth term. Okay, so I think some of us may still use like the t of n, right? Or you could use the a sub n equations, but these are the equations for the nth term describing the pattern in a sequence or a series. Okay, so if we look at this here, right, we know that we're trying to figure out what term number 400 is, right? We don't know. We know that like 5 is like the first term, 10 is like the second term, the third term, but we don't know what 400 is at the end. So this is like our a sub n term. Okay, and we can actually even name these. This would be like a sub 1, a sub 2, a sub 3, just means the third term. Okay, so remember our formula goes like this. We'd say we'd do a sub n equals the first term, so a sub 1, plus the common difference, right? And our common difference here, right, we're going through, it's like we're adding 5 each time as you're going across. So plus the common difference times n minus 1. Or if we're using the t of n's, it'd be like saying t of 1 plus d times the quantity of n minus 1. Remember, this is what we call first term form. We're not using 0th term form. We're using first term form now. So you may want to get used to that. Okay, so let's go ahead here and let's figure out what n is going to be in this one. So we know that a sub n, right, a sub n is 400. So let's just go ahead here and let's put that in. We have 400 is equal to our first term. Our first term here is 5. So we're going to put that in. So we've got 5 plus our common difference we said was 5 times the quantity of n minus 1. We're trying to figure out what n is, so you don't want to put anything in for it. Let's just go ahead and distribute the 5 through so we can simplify over here. We have 5 plus 5n minus 5. This 5 and this 5 will cancel out, so we have 5n is equal to 400, which tells us then that there are going to be 80 terms in this series, which means this is our 80th term. 80 terms in the series. That should help us then to be able to find the sum. Remember, we're not doing it with the formula here. We're using the method that Carl Gauss used. There, we're adding the two series together. So let's start out by writing down the first series. We'll say the sum of the first 80 terms is going to equal, you don't have to write out every term. Let's do it like this. Let's do 5 plus 10 plus ... plus 395 plus 400. So I just have 2 on either end there. So when I take it here and I add it, I'm going to add it to itself. So I'm going to say here plus the sum of the first 80 terms, but I'm going to write them backwards. 400 plus 395 plus 10 plus 5. Okay, and really, I mean, you don't have to write out that many, just as long as you figure out what the sum of those numbers is going to be, right? So we had 80 terms here. We have 80 terms here. So that means in our answer, we're going to end up with 80 terms, and they're all going to end up being 405, right? If I add all those together, I get 405. Now, you don't have to take them and write them all out. I'm just doing it for the notes. Really, this value, though, is the same thing as saying 405 times 80, because we know we have 80 of those 405s there. So 405 times 80 should equal 2 times the sum of the first 80 terms. Well, first thing we need to do is figure out what 80 times 405 is going to be, and I believe that ends up being like 32,400. Use a calculator for that. There's no shame in that at all. We have 2 times the sum of the first 80 terms, right? And then to get just one set of those first 80 terms, we're going to divide each side by 2. And we get the sum of the first 80 terms should equal 16,200. And that is the answer for that problem. Hopefully you got it right. If so, go ahead and move on. If not, you can go back and watch the video here if you need to see what you did wrong, or reach out to your teacher. Thanks for watching.